Lesson 1.7, Writing Literal Equations. What is a literal equation? A literal equation is a written equation. So if something's literal, it means it's in writing, it's written down. It's a written equation with two or more variables. Now, a type of literal equation can be formulas. A formula shows how one variable relates to another. To rewrite literal equations, we must solve for one variable in terms of the other. I'm going to show you what this means, but first I have an example. So as many of you know, last summer I went to Peru, and Peruvians measure temperatures in Celsius. They were astonished to hear that Houston can reach 104 degrees in the summer, and they wanted to know, what would this be in Celsius? So let's convert. We're going to use the formula Celsius equals 5/9 parentheses F, which that stands for Fahrenheit, minus 32. Why do you think there's a 32 here in the formula? Well, 32 is our freezing point, and it's super important for this example. So let's plug in what we know. We don't know the Celsius, but we do know the temperature in Houston. So I'm using 104 because that's the hottest summer I can remember. Okay, 104 minus 32 is 72. Now I need to figure out what 5/9 is of 72. So what I'm going to do is I'm going to multiply 5 over 9 times 72 over 1. And this is just a neat trick with fractions, but if we recognize a common denominator or a common factor between, we can simplify. I'm just moving this over here so I have more room. Okay, I know that I can eliminate. Both 9 and 72 are divisible by 9. So when I cross simplify, I can eliminate that 9 and simplify out a 9. So 72 divided by 9 is 8. So now I have this fraction. Okay, now that when I multiply, I get 40 over 1, which is just 40 wholes. So that means if it is 104 degrees Fahrenheit outside in Houston, that would be 40 degrees Celsius. Now the tour guide says it's 5 degrees Celsius, but Mr. McMahon and I are uncertain. What is that degree? What is that temperature in Fahrenheit? Okay, so we're going to reuse this equation, this literal equation right here. It's a formula for Celsius. And we're going to rewrite this. I'm going to change colors to solve for Fahrenheit. So remember before I said to solve, we must solve in terms for another. So right now we're solving for C, Celsius, but we want to rearrange this so that we're solving for F, Fahrenheit. So I want you to think, how can we get F by itself? Well, first we have to get rid of this 5/9. I want you to think, what should you multiply 5/9 by to make it one whole, as if we're trying to get rid of it? Well, we're going to multiply it by its reciprocal. The reciprocal is when we flip the numerator and the denominator. I'm doing this so I can get rid of the fraction that's in front of the parentheses. So that means I'm going to multiply both sides by 9/5, its reciprocal. And this is cool because it cancels out my fraction. Now I no longer have a fraction in front of my parentheses. Okay, so I know that's kind of a lot. So now I have 9/5 C equals F minus 32. And again, we're trying to solve for Fahrenheit. We need to get F by itself. So to do that, I'm going to add 32 to both sides. Now it's kind of out of order, but now I'm going to rewrite this. F is equal to 9/5 Celsius plus 32. I apologize, my work is a little messy. And all we did was rearrange this equation to solve for F. Okay, I'm going to clean up this work and erase this right here. If you need it still, pause the video or go back and rewind. Okay, so we're given that it's 5 degrees Celsius. So in place of C, I'm going to put 5. And I know I'm going to be multiplying that by 9/5. And then adding 32 to whatever that total is. When I multiply 9/5 times 5, I get 9. Now I have 9 plus 32, which is 41 degrees. Okay, so if our tour guide said it's 5 degrees Celsius outside, we can think in America, this would be 41 degrees Fahrenheit. It gets tricky when you travel and run into different temperatures. So I just wanted to share with you that fun example and how we can use this in the real world. Okay, so now we're going to do some practice with variables. We are now going to solve the equation for y. And notice on your note sheet, you have a little check area. For here, I want you to think, okay, we're going to be looking at the steps. What steps do we need to solve the equation for y, or in some examples, solve the equation for x? All right. So I have y plus 5x equals 17. And I want to solve this for y. So what I must do is I need to isolate y. So I need to get y by itself. And to do that, I'm going to subtract 5x from both sides. This is all I need to do to solve for y. So what step I did? I undid the 5x by using the subtraction property of equality. So I'm just going to abbreviate that with just subtraction minus 5x. Okay, please pause the video, and I want you to solve in terms for y. We have 4y minus 36x equals 28. Again, pause the video, and in just a bit, I'm going to reveal the answer. Okay, let's check. Ooh, sorry. When I erase, there's a way I can do it, either whole or partial. Okay, so when we solve for y, notice the first thing we have to use is we have to use addition to cancel out the minus 36x. And to do that, so we're adding 36x to both sides. And then the next thing we're doing is we're using division to get rid of the 4 in front of the y. I like to show division as a fraction because then you can simplify and see, okay, I'm dividing both this by 4 and that value by 4. And so when we rewrite it, we get y equals 9x plus 7. Man, this makes me think of functions and when we graph equations. Okay. Now pause the video again. We're solving this time for x. We're going to have to do a couple of things before we solve for x. Okay, now I'm going to reveal the answer. So notice the first thing I did before I solved for x is I had to combine like terms. And then once I combine like terms, I use division to solve for x. And we get x is equal to y over 7. Again, this is the same thing as saying y divided by 7. However, mathematically, you're going to see it most often as a fraction. Okay, we have one more example for today. And this is something that you're going to use in geometry. Find the formula for the volume of a cylinder, then rewrite in terms of the height. So let's look at parts of a cylinder. I have a cylinder drawing here for you. It's important to note that when we measure a volume of cylinders, we need the radius and we need the height. So when we measure the volume, we generally use this equation, V equals big B times H. And just as a little review, this is the area of the base. So that refers to our circle. So I kind of answered the question I was about to ask. I was going to ask, what shape is the base of the cylinder? It's a circle. So the volume would be pi r squared, the area of the base, times the height. I need to rearrange this so I'm solving for h. What's cool is I can divide this whole volume formula. Now I might need to move my formula a little bit. Whoops. Uh-oh. Okay. I need to move this formula a little bit so I have some more room and it doesn't get too messy. So I need to divide everything by pi r squared. It'll cancel out the pi r squared on top. And it'll allow me to solve for height. Volume equals pi r squared, height equals volume, that's a big capital V, divided by pi r squared. And you guys, this is our answer. All we had to do in this question was rewrite in terms of the height. Thank you so much for watching this video, and I hope you have a great day.